Welcome to the week 6 of our calculus class. Last week, we talked about critical numbers and finding location of local extrema, local maxima, local minima. As part of looking for the locations of a local maxima and minima, we discovered that we needed to know the domain of the function. So, today, we'll review how to find the domain of a composition function. Let's start with the basic functions that have no restrictions on the domain. Here's an example. Polynomials. Polynomial is a function that always has x raised to some integer positive power, maybe multiplied by a constant, and there would be different terms added together. Parabola is a good example of a polynomial of degree 2. 3x squared plus 2x minus 7 has no restrictions on x. X can be any real number. Another function is a polynomial of degree 3. f of x equals x cubed has no restrictions on the input values of x. Another type of function that has no restriction is an exponential function, where a is a constant, and constant can be any real number, strictly positive. Input variable x can be any positive, negative number, 0, no restrictions whatsoever on the value of x for any exponential function. For example, f of x equals to a half raised to exponent x has no restrictions, same as e to the x. Another interesting example are irrational functions. F of x is equal to the nth root of x, where n is odd, positive integer. For example, cube root of x has absolutely no restriction. X can be any number from minus infinity to plus infinity, and so is the fifth root. Now let's recall some examples of basic functions that do have restrictions on the domain. For example, logarithmic function. A logarithmic function can have a base a, that is any positive number, but it requires that the input x is also strictly positive. For example, logarithm with the base 2 of x takes as an input any strictly positive number. The same as a natural logarithm of x that has the base e. Irrational number where n is even positive integer also has restrictions on a domain. For example, square root of x does not take as an input any negative number, so x must be greater or equal 0. This is true for any even root. For example, x to the 1/4. Important examples are rational functions, which is a polynomial divided by a polynomial. As long as the denominator is not equal to 0, the rational function is defined at the value of x. However, the restrictions come from the values of x that make denominator q of x equal to 0. So, those values of x are not allowed in the domain of the function. For example, 1 over x. It's a rational function. Since x equals 0 makes denominator equal to 0, x equals 0 is not allowed, which restricts the domain to intervals from minus infinity to 0 and from 0 to plus infinity. Another example of a rational function is the function f of x equals to 2x divided by x squared minus 4. Because x squared minus 4 is equal to 0 at 2 and negative 2, those two values of x are not allowed in the domain of the function. So now that we reviewed the domains of the basic functions, let's talk about the domain of a composition function, f of g of x. How do we find out what the restrictions are? Well, we start with the function g of x and identify values of x that are not allowed to be in the domain of the function g of x. Then we'll find the restrictions on the domain of the outer function, f of u, and find out which inputs u are not allowed in the domain of the function f. And as a last step, we exclude not only all the values of x that are not allowed in the domain of the function g of x, but also we exclude all of the values of g of x that produce values of u not allowed in the domain of the function f. Let's take a look at the example. Let's say we want to identify the domain of the function square root of 2x minus 6. The outer function is square root, the inner function is 2x minus 6. Let's start with the inner function. g of x equals to x minus 6 has no restrictions on the domain. It's a polynomial of degree 1 that has no restrictions. The outer function f of u is a rational function. An irrational function with n equals to 2 has restrictions. The input has to be greater or equal to 0. Therefore, as long as input u is greater or equal to 0, the values of x are allowed. Therefore, g of x equals to 2x minus 6 has to be greater or equal to 0. Solving this inequality, we determine that x must be greater or equal to 3. Therefore, the domain is any real number starting from and including value 3. Let's consider one more example. Let's find the domain of the function y equals natural logarithm of absolute value of x. The inner function is absolute value of x, and it has no restriction on its domain. X can be any positive, negative number, or 0. The outer function f of u equals to natural logarithm of u has a restriction. The input value u has to be strictly positive. Therefore, g of x, which acts as an input for the function f, has to be strictly positive, which means that we're allowing all values of x that are not equal to 0 in the domain of the function. Our domain is from minus infinity to 0 and from 0 to plus infinity. I hope you found this exercise useful. I'll see you next time in class.